Imagine for a moment that you're looking at the night sky and seeing the Milky Way stretching majestically overhead. Now, get ready to have your minds completely transformed. Our entire galaxy, with its 400 billion stars, is just a grain of sand in a cosmic structure so gigantic that it would take 520 million years to traverse it at the speed of light. And the most impressive part, we live inside it, and it has a name, Laniakea. Today, we're going to embark on a journey through the universe's greatest architectural mysteries. We'll discover that our cosmic home is much larger than we imagined, that there's a mysterious force called the Great Attractor, pulling billions of galaxies in a silent cosmic dance, and that there's something even more enigmatic called dark flow, that might be rewriting everything we thought we knew about the cosmos. Get ready to learn about natural megastructures so colossal they defy our understanding of physics. Welcome, cosmic explorers, to the Cosmic Frontiers channel. I am your guide on this extraordinary journey through the mysteries of the universe. And today we're going to expand our perspective in a way that will leave you looking at the night sky with completely different eyes. Let's begin our exploration by understanding exactly where we live in the universe. When we look at the night sky, we see the Milky Way, our home galaxy. But the Milky Way isn't alone in space. It's part of something much larger, a structure that scientists recently discovered and that has completely changed our understanding of our cosmic address. In 2014, an international team of astronomers led by Brent Tully from the University of Hawaii made a revolutionary discovery. They mapped the movements of more than 8,000 galaxies in our region of the universe and found that all of them, including our Milky Way, are part of a colossal structure they named Laniakea. The name comes from Hawaiian and means immense celestial horizon, a perfectly fitting name for something of such unimaginable size. To understand the size of Laniakea, let's use an analogy. If Earth were the size of a marble, our Milky Way would be like an entire city. Now, Laniakea would be like an entire continent covered by thousands of these cities. We're talking about a structure that contains approximately 100,000 galaxies, each with billions or trillions of stars. It's literally impossible for our human mind to fully comprehend this scale. But here's the most fascinating part. Laniakea isn't just a random grouping of galaxies. It's an organized structure, with rivers of galaxies flowing like cosmic currents towards denser regions. Imagine a gigantic river system, but instead of water, its entire galaxies flowing through space, following invisible paths determined by gravity. What makes this discovery even more impressive is that we were only able to map Laniakea recently because we developed techniques to measure not just where galaxies are, but where they are moving. It's as if we had finally been able to see the currents of a cosmic ocean that had always been there, but was invisible to us. Now, you might be wondering, what's causing all this movement? What's pulling these galaxies in specific directions? This is where our journey gets even more mysterious, because we enter the territory of one of the universe's most enigmatic forces, the Great Attractor. Imagine you're in a river and you feel a powerful current pulling you in a specific direction. You know there's something downstream causing this current, but you can't see what it is because there's a bend in the river blocking your view. This is exactly the situation we find ourselves in with the Great Attractor. The Great Attractor is a region of space that is pulling our Milky Way and thousands of other galaxies towards it with immense gravitational force. Discovered in the 1970s by astronomers who noticed that our galaxy was moving in a specific direction at a speed of 600 kilometers per second. The Great Attractor remained a mystery for decades. The problem is that the Great Attractor is located behind what astronomers call the zone of avoidance, a region of the sky where the dust and stars of our own galaxy block our view of what lies beyond. It's like trying to see through a dense wall of smoke. For years, scientists knew something massive was there, but they couldn't see exactly what it was. It was only in recent decades, with the development of infrared and X-ray telescopes that can penetrate through the dust, that we began to unravel the mystery. What we discovered was even more impressive than we imagined. The Great Attractor is not a single object, but rather a complex region containing several massive clusters of galaxies. The most fascinating thing is that the Great Attractor itself is being pulled by something even larger and more distant. It's like discovering that the river that was pulling us actually flows into an even vaster ocean. This discovery led us to understand that the universe is structured in a hierarchy of gravitational influences, where smaller structures are attracted by larger structures, which in turn are attracted by even larger structures. But our journey through cosmic mysteries is just beginning, because there's something even more enigmatic happening on even larger scales. The dark flow. Imagine you're observing a river and you notice that, in addition to the normal current you expected, there's an additional and mysterious movement of the water in a completely different direction. This is essentially what astronomers discovered when they began studying the movement of galaxy clusters on even larger scales than Laniakea. The dark flow was discovered by a team led by Alexander Koshalinsky from NASA. When they were studying the cosmic microwave background radiation, essentially the oldest light in the universe, they expected to see small random variations in this radiation, but instead found something completely unexpected. A pattern that suggested huge regions of the universe were moving in a specific direction at speeds of hundreds of kilometers per second. What makes the dark flow so mysterious is that it cannot be explained by the distribution of matter that we can observe in the universe. According to our standard model of cosmology, the movement of galaxies and clusters should be determined by the gravitational attraction of visible matter and dark matter in our region of the observable universe. But the dark flow suggests that there is something beyond the observable horizon, something we cannot see, exerting a gravitational influence on our region of the cosmos. Think about this for a moment. We're talking about the possibility that there are structures or concentrations of matter so distant that their light hasn't had time to reach us since the Big Bang, but which are so massive that their gravitational influence can affect the movement of billions of galaxies in our region of the universe. It's like discovering that there are invisible mountains on the other side of the planet that are affecting the tides on our coast. This discovery has profound implications for our understanding of the universe. If the dark flow is confirmed, it would mean that our observable universe, everything we can see with our most powerful telescopes, is just a small part of a much larger reality. It would be like discovering that our city is not just part of a country, but that this country is part of a continent, that is part of a planet, that is part of an even larger system that we cannot even imagine. Now, let's take a step back and contemplate what all these discoveries mean for our understanding of cosmic megastructures. The universe is not just a random collection of stars and galaxies scattered through space. Instead, it is organized in a complex hierarchy of structures, each one more impressive than the last. At the most basic level, we have stars grouped into galaxies. Our Milky Way, with its 400 billion stars, is already a structure of unimaginable size. But galaxies group into clusters, which can contain thousands of galaxies. These clusters, in turn, organize into superclusters like Laniakea, and now we know that even superclusters are part of even larger structures, influenced by forces operating on scales that challenge our understanding. What is truly impressive is that these structures are not static. They are in constant motion, evolving and changing over billions of years. Laniakea, for example, is not a permanent structure. In a few billion years, the accelerated expansion of the universe will cause the most distant galaxies to move so far away that they will no longer be gravitationally bound to the supercluster. It's like watching a cosmic dance in super slow motion, where partners approach and recede over geological ages. These discoveries also make us question some of the fundamental principles of our cosmology. The cosmological principle, which states that the universe is homogeneous and isotropic on large scales, may need to be revised in light of these megastructures and directional flows. It's possible that the universe is much more complex and structured than we thought. Furthermore, these discoveries remind us how little we still know about the cosmos. Dark matter, which makes up about 27% of the universe, remains completely mysterious. Dark energy, responsible for the accelerated expansion of the universe and making up about 68% of everything that exists, is even more enigmatic. We are literally exploring a universe where 95% of everything that exists is invisible to us. But perhaps the most fascinating aspect of these cosmic megastructures is what they tell us about our own existence. We are not just inhabitants of a planet orbiting a star in a lost galaxy in space. We are part of a complex and interconnected cosmic structure where our Milky Way is participating in a gravitational dance, involving 100,000 other galaxies in Laniakea. Every atom in our body was forged in the core of stars that lived and died billions of years before our solar system existed. These atoms traveled through intergalactic space, were incorporated into gas clouds that collapsed to form new stars, and eventually found themselves on Earth to form complex molecules that became life. We are, literally, stardust organized in a way that can contemplate the universe from which we emerged. The discoveries about Laniakea, the Great Attractor, and the Dark Flow show us that our cosmic history is even more epic than we imagined. We are not just products of evolution on an isolated planet, but participants in a cosmic saga involving structures of unimaginable size and forces, operating on timescales that defy our understanding. These cosmic megastructures also make us reflect on the future. In a few billion years, our Milky Way will collide with the Andromeda Galaxy, creating a new galaxy that astronomers have already dubbed Milky Way. This galactic collision will be part of the continuous evolution of cosmic structures, a reminder that even the largest constructions in the universe are constantly changing. Meanwhile, the accelerated expansion of the universe will continue to separate the most distant structures. In trillions of years, galaxies that we can observe today will be so distant that their light will no longer be able to reach us. The observable universe of the future will be much smaller and lonelier than what we see today. But for now, we live in a golden age of astronomy, where we have the technology to map these colossal structures and the curiosity to ask the right questions. Every new discovery brings us a little closer to understanding our true position in the cosmos and our connection to the fundamental forces that shape the universe. So, cosmic explorers, the next time you look at the night sky, remember that you are seeing only a small fraction of our true cosmic home. You are observing from within Laniakea, being carried by the gravitational flow towards the Great Attractor, participating in a cosmic dance that involves 100,000 galaxies and that may be influenced by structures so distant that we cannot even imagine them. Recapping our journey today, we discovered that we live in Laniakea, a supercluster with 100,000 galaxies stretching for 520 million light-years. We explored the mystery of the Great Attractor, a massive gravitational force that is pulling our region of the universe in a silent cosmic dance. And we encountered the enigma of the Dark Flow, which suggests that there are structures beyond our observable horizon, influencing the movement of billions of galaxies. This leads us to a profound reflection. If we are part of such vast and complex structures, connected by forces operating on unimaginable scales, what does this mean for our understanding of who we are and what our place in the universe is? Are we insignificant observers in an indifferent cosmos? Or are we the way the universe developed the ability to know itself and marvel at its own grandeur? Cosmic explorers, I want to know what you think about these megastructures of the universe. Which of these discoveries impressed you the most? Laniakea, our home supercluster, the mystery of the Great Attractor, or the possibility that the Dark Flow reveals structures beyond our observable horizon? Share your reflections in the comments. I love reading your perspectives on these cosmic mysteries. And since we're talking about the mysteries of the universe, what cosmic enigma do you want me to talk about in the next video? Supermassive black holes, the nature of dark matter, the possibility of parallel universes. Leave your suggestions in the comments. You are the ones who guide our journey of exploration. We are on an incredible journey towards 1,000 cosmic explorers. If this video expanded your perspective on our cosmic home and sparked your curiosity about the mysteries of the universe, join our crew by clicking subscribe. Together, we will continue to explore the frontiers of human knowledge and unravel the deepest secrets of the cosmos. Like this video if it transformed your understanding of where we live in the universe, and share it with someone who is also fascinated by cosmic grandeur. In the next video, we will delve even deeper into the mysteries of space-time and discover how the very fabric of reality can be bending and distorting around us. Until then, keep looking at the stars and remember, you are not just observers of the universe. You are the universe observing itself. See you at the next cosmic frontier.